Hi, this is Dr. Kurt Wohler for Integrative Medicine Academy and Great Plains Laboratory. The title of this video is Acrolein Exposure, Toxicity, and Associated Health Problems. So I'm Dr. Kurt Wohler. I've been an integrative and functional medicine physician since the late 90s. Done a tremendous amount of clinical education for Great Plains Laboratory through seminar instruction as well as years of webinar production. I do a lot of speaking. I'm an author, educator, and practicing clinician. I'm co-founder of Integrative Medicine Academy, as well as medical director of Functional Medicine Clinical Rounds, two resources for healthcare practitioners interested in learning more about integrative and functional medicine. Now, in my own practice, I've worked with individuals on the autism spectrum now for many years, patients with autoimmune disease, gastrointestinal, and neurological disorders. So one of the key elements here with this particular video in this lecture is the information I'm going to present really should push you to think critically and think clinically about the type of patient you're working with, and really how to expand your knowledge base regarding some of the tests that Great Plains provides, what some of these markers mean, and again, how things apply or correlate to that patient or client that you're working with in practice. So Great Plains has the organic acid test. This to me is a game changer in clinical practice. It is a test that looks at many different markers of metabolism that are a reflection of imbalances in body metabolism, but also could be a reflection of toxins being produced within the digestive system, for example, Clostridia bacteria or fungal overgrowth. The GPL-TOX Profile is a wonderful test that looks at a wide variety of environmental chemicals. And there are certain markers on the organic acid test that can be elevated because of the presence of certain environmental chemicals, like succinic acid under the Krebs cycle metabolite section of the oat is often elevated when we have chemical or heavy metal exposure. So I think it's incredibly worthwhile to learn how to use the GPL-TOX, also called the non-metal chemical profile. Because again, there is a wide variety of environmental chemicals that we and our patients are exposed to, from pyrethroid insecticides to benzene, xylene, plasticizers, organophosphates, something called 2,4-D, which stands for 2,4-dichlorophenoxic acetic acid, which is a common weed killer, and many other compounds. One of the chemicals that often shows up elevated, and I see it probably about 80% of the GPL-TOX profiles that I see in practice, have an elevated level of a chemical called acrolein, which is also called 3-hydroxy propyl mercapturic acid, which is the main metabolite. And in some cases, it's extremely high, well above the 95th percentile when it's felt to be most clinically significant. It's not that it couldn't be an issue at a lower level. And one of the things about this chemical, the acrolein, is it can occur because of different exposures sources, but it can cause a wide variety of health problems. So two well-known ones are insulin resistance as well as diabetes. So acrolein is a colorless liquid that has a very strong smell. It smells like burnt fat, essentially. And this occurs when glycerol, which is a component of fat, breaks down into acrolein. Now, small amounts of acrolein can be formed and can enter the air from trees, tobacco, as I mentioned, oil being burned, gasoline, and other plants. So we know that it has various uses and occurrences. So it can be used in the chemical or in industrial production as a precursor chemical for other chemicals. It's often used as a biocide agent. Cigarette smoke could be a source of acrolein. It also shows up sometimes as a chemotherapy metabolite. So cyclophosphamide, by the way, is a chemotherapy drug that's often used for lymphoma and leukemia. And so acrolein can accumulate in the urinary bladder, and in a high enough level can lead to what's called hemorrhagic cystitis. So acrolein is often used as an algicide. So it's added to irrigation canals, for example, to help kill off algae or these floating weeds. As a biocide, it's often used in the oil and gas industry. So what it does is it scavenge certain chemicals like hydrogen sulfide, for example. It is a strong irritant to the eyes, nasal passages, and skin. That's only sort of part of its negative effects on health. And the metabolism of acrolein primarily occurs through what's called glutathione alkylation. We know that glutathione effects in liver metabolism take place primarily through phase 2 liver detoxification. So in order to get the 3-hydroxypropyl mercapturic acid, which is the sort of the metabolite of acrolein essentially, and there's a couple ways that acrolein is broken down, but what's called alpha ketoreductase, this is an oxoreductase reaction that eventually leads to the presence of the metabolite of acrolein that registers on the organic acid test. So basically what the GPL-TOX profile. So what's happening is on the GPL-TOX profile, we're getting exposed to acrolein, but because of detoxification reactions in the liver, we end up with the 3-HPMA as a reflection of acrolein exposure, and then of course it's expressed in the urine. Now, liver detoxification is incredibly important to understand when it comes to the presence of these different types of chemicals. So at a simple level, we have lipid-soluble chemicals that we accumulate in our body. And of course, we have our own chemicals that we produce that sometimes need to be metabolized as well through liver detoxification. But in essence, if we think about an environmental chemical like acrolein, it will go through phase 1, which is now taking a chemical that is lipid-soluble and starting to transform it into a water-soluble form. And the type of reactions that occur in phase 1 are hydrolysis, for example, as well as what's called oxidation and reduction. Now, there's always the intermediary phase of liver detoxification. And that's where we're most vulnerable to these reactive oxygen intermediates, the oxidative stress, which is why we need a lot of antioxidants in our diet. Glutathione conjugation, sulfation, for example, are what take place in phase 2, and that's ultimately leading to the final transformation in taking a lipid-soluble chemical and making it more water-soluble so that it can be excreted more effectively in the urine or in our feces. So, aldehydes. An aldehyde is a functional group that has a carbon. So right here would be a carbon, double bonded to an oxygen, single bonded to a hydrogen. So that, by definition, is an aldehyde. And these are reactive type of chemicals that, unfortunately, can lead to a lot of toxicity. Now, it turns out that bacteria in the digestive tract sometimes can produce acrolein, okay, through what's called glycerol metabolism. And they act, or what's called, acrolein acts as what's called an electrophile. An electrophile is a chemical species that accepts an electron pair and acts as an oxidizer. So it's causing an oxidation reaction, which can create imbalances chemically on other chemicals. So if we just think it from a simplistic general chemistry standpoint, and there are different ways of defining a reducing and oxidizing agent, but in this particular example, we're talking about the movement of electrons between one element or one compound and another. So if we look, for example, at sodium and chloride, so sodium having a plus charge, chloride having a negative charge, if we transfer an electron from sodium to chloride, that moves to what's called a reduction, oxidation, or oxidation type of reaction. So oxidation is the loss of an electron. So when something becomes oxidized, it's losing an electron. Something that becomes reduced in that chemical reaction is gaining an electron. And another interesting way of just looking at this, because I think it's important for us to have at least some visual of what is called a free radical and how some of these things might damage DNA or proteins or other cellular structures. We can certainly do it with reactive oxygen species where there's an unpaired electron. But if we just took a common free radical, so our outer shell, in a free radical would have an unpaired or a space, for example, where there's a missing electron. So a stable molecule generally will have a valence shell of 8 electrons. So let's say, for example, our free radical only has 7, so it'll want to go grab an electron from something else. So in this case, it's grabbing an electron from DNA, filling that void, allowing the molecule to become more stable, but what it leaves behind is a damaged DNA. And antioxidants help to sort of bridge that gap or prevent that reaction from occurring. So essentially an antioxidant will donate an electron, fill the space in that valence shell, make the free radical happy, more stable. That's the role of an antioxidant. So acrolein and other aldehydes. So the one thing to just keep in mind is that aldehydes, because of the functional group, can have high chemical reactivity. So there are various enzymes that deal with aldehyde. So aldehyde dehydrogenase, for example, is an enzyme or group of enzymes that we have to deal with chemical aldehydes. And there are many different types of aldehydes. So acrolein is one, croton aldehyde, for example, hexanol is another example. Formaldehyde is a type of aldehyde. Acetaldehyde is another aldehyde that we can either come in contact with through ethanol consumption. So essentially, if we consume ethanol, it can get converted into acetaldehyde, or the overgrowth of yeast within our digestive tract can convert glucose into acetaldehyde. And acetaldehyde is quite problematic. Not only is it an aldehyde, so it can be highly reactive chemically, but acetaldehyde, by the way, can actually interfere with the methylation cycle. So this slide actually came from a very in-depth article on aldehyde toxicity and metabolism. So the bottom line is that these aldehydes can damage DNA. They can generate reactive oxygen species. They can damage proteins, damage mitochondria, deplete glutathione, and have other kinds of effects. So they can cause oxidative stress, mitochondrial damage, even trigger and be involved in cancer. So take this to another level when you start thinking about acrolein exposure. Chronic exposure over time could end up triggering different types of inflammatory chemicals, tumor necrosis factor, interferon gamma, for example. These can drive inflammation. That can lead to tissue injury, inflammation throughout the body. Interestingly enough is that acute exposure could end up causing immune suppression at a very high dose, for example. And one of those things is interleukin-2, interference with interleukin-2. And when we look at the innate and the adaptive immune system, okay, we know that the innate immune system is things like macrophages and monocytes, neutrophils, this sort of system that tends to respond in much the same way each time we encounter an antigen. Our adaptive, or what's also called our acquired immune system, is trained, or it learns in essence from its exposure. So if we have an antigen of some sort, could be a virus, could be a bacterial protein, it gets presented to an antigen presenting cell, like a dendritic cell, and it will present its antigenic information to our lymphocytes, to our adaptive immune system. And so we have a naive CD4 cell that interacts through a receptor with the antigen presenting cell. And then it has a decision to make. Is it going to go off to become a Th2, a T helper 2 cell, or is it going to go off to become a Th1, T helper 1 cell? So a T helper 1 will move more into cellular immunity, and it will help form memory T cells, but it will also produce other cytokines like interferon gamma and interleukin 12 to engage aspects of the innate immune system like a macrophage to induce first-line immune defense. It could also go off to become a Th2 CD4 cell, which stimulates B cells to produce plasma cells, which make our antibodies. And so interleukin 2 plays a significant role in helping to prime the T helper immune response. It even communicates with T cytotoxic cells, which go off and end up just directly killing a cell, for example, that might be virally infected. So we can see that just interleukin 2 plays a role in helping to regulate communication between the humoral as well as the cellular immunity, but that also has a link back or communication back to the innate immune system. And so this is important because an acute high dose exposure of acrolein can end up causing immune system problems that not only could negatively impact our adaptive immunity, which would be our T cells and our B cells, but it could compromise even innate immune function as well, which would essentially leave us sort of exposed or more prone to secondary infections. And remember, the adaptive immune system is our T cells and our B cells. B cells are, the main cells that are given credit to actually producing antibodies, but it actually turns out that there are antibodies that are produced by our innate immune system as well. T cells, we know through cytotoxic T cells, can kill virus-infected cells. There can be regulatory T cells, and they do aid in some antibody production as well. So let's take it back to the level of the gut, right? So gut microbial glycerol metabolism and endogenous acrolein source. So it's possible that just an overgrowth of opportunistic bacteria in the digestive tract could be a source of acrolein. And we have established, because acrolein has that aldehyde group, we know that it is a reactive chemical that could generate a lot of free radical damage, which can cause tissue damage, cellular dysfunction, membrane damage, etc. Okay, so just a bacterial cell ultimately leading to acrolein, which we know has that aldehyde group, which is a highly reactive, it's called an electrophile. So it can take electrons, causing an oxidation reaction. And one of the things that can produce acrolein is Clostridia bacteria. And so this is where the use of the organic acid test is important to understand, because if you look at page 1 of the organic acid test, we know it's got the yeast fungal markers, it's got bacterial markers, but at the bottom of page 1, it's got 4 markers which are linked to different types of Clostridia bacteria. The most common marker to show up is the HP-HPA, but we also many times see 4-creosol and 4-hydroxyphenylacetic are elevated as well. And so it is possible that in any given patient, if we find an elevated acrolein from the GPL-TOX, that it could be coming from Clostridia overgrowth if those are actually represented on the oat, or at least that's in part why the acrolein might be high. And if we expand this out even further, and it's to understand that Clostridia bacteria can have a negative effect on dopamine. Now, this occurs through an expanded discussion that I've had in many other videos and lectures and webinars for Great Plains, as well as my own Integrative Medicine Academy. But Clostridia toxins, particularly the HPHPA4 creosol, but also the 4-hydroxyphenylacetic, can interfere with dopamine metabolism, where it blocks the ability of dopamine to get converted to norepinephrine. So it has an inhibitory effect on an enzyme called dopamine beta hydroxylase. And in the nervous system, that can cause dopamine to build up. So about 90% of dopamine is stored in terminal vesicles of a neuron. So about 10% of it is sitting out in the cytosolic fluid. So small percentage shifts in that cytosolic dopamine can create a compound, or an overexpression, I guess you would say, of a chemical called dopamine-O-quinone. Now, dopamine-O-quinone can trigger apoptosis, so essentially a cell committing suicide. And so we have glutathione in our cell to try to counter the dopamine-O-quinone to make it less toxic. But if we already have things that are draining our glutathione, that can allow for more of that dopamine-O-quinone to have its downstream toxic effects. And one of the things it can do is it can generate oxygen-free radicals that ultimately lead to neurodegeneration. So here is that slide I wanted to show you with regards to the inhibition of dopamine beta hydroxylase. So we've got Clostridia difficile, we've got other Clostridia bacteria, and they'll produce certain chemicals like this 4-creosol or HPHPA found on the organic acid test. And these chemicals can interfere with dopamine beta hydroxylase. And when they inhibit enough of it, we can get an increase of dopamine, which we already know now can lead to that increase of dopamine-O-quinone. But on the organic acid test, we can see increases of homovinylic acid as a representation of this inhibition. So dopamine not getting converted to norepinephrine. And if the reaction is strong enough, we'll actually see a drop in norepinephrine as a decrease in vanillomandelic acid. So we can get large increases of homovinylic acid, very low vanillomandelic acid. And this can have a problem because we need norepinephrine to engage the immune system. We need norepinephrine to produce epinephrine for energy production. It has an effect on the cardiovascular system with regards to peripheral vascular pressure and allowing for improved blood flow throughout the body. For-creosol is another bacterial phenol chemical that is produced by certain Clostridia, and they're toxic. Essentially what they could do is interfere with metabolism again of dopamine. And so what ends up happening is these bacterial phenols, the for-creosol, the HPHPA, can interfere with dopamine beta hydroxylase. And if we interfere with dopamine beta hydroxylase, we don't get adequate conversion of dopamine to norepinephrine. And that's where we have the downstream toxic effects of too much dopamine. Now, when the creosol, in this case, binds to the dopamine beta hydroxylase, it renders it completely inactive. That doesn't mean every single dopamine beta hydroxylase in the body is being affected, but we get enough of it, whether it's in the peripheral nervous system, central nervous system, it will affect dopamine metabolism. So the key point here is that Clostridia could be a source of acrolein. You'd have to do the GPL-TOX to know for sure. And the existence of Clostridia has other toxic effects, which is why you always do the organic acid test. In this particular case, leading to increases of the dopamine-O-quinone. And this was an interesting paper. They're looking at dopamine-quinone, okay, generating inflammation, generating oxidative stress, causing mitochondrial dysfunction. And this one right here is important, particularly if you're working with patients with neurodegenerative diseases, Alzheimer's, Parkinson's, etc. The ubiquitin proteasome system is very important, is because this system, ubiquitin is ubiquitous protein, the proteasome helping to break down dysfunctional old protein is really important. So the ubiquitin proteasome system breaks down old proteins that either aren't needed anymore or maybe were malformed originally, and we need to get rid of them. Okay, and if we inhibit that ubiquitin proteasome system because of an increase of dopamine or quinone, because of an overgrowth of Clostridia bacteria, we now put the cell and even in a more compromised state, because these dysfunctional proteins will just, sort of muddy up the waters here or kind of get into the gears of the cell and completely disrupt function. And that's something that is being correlated again in many neurodegenerative diseases. So the key point with this is that the organic acid test is important to understand its key components, the Clostridia for sure, also looking at certain markers that could be related to chemical exposure like elevated succinic acid. And the GPL-TOX profile is very important to be able to assess for an individual's chemical exposure. And then we can sort of merge the two to see what might be happening. And in the context of this talk, particularly with regards to Clostridia being a potential source for acrolein, which you will see about 80% of the time elevated on the GPL-TOX. There's a lot of it out there in the environment. Now, also, it's just to understand too that acrolein being an aldehyde, okay, has toxic effects because it can create oxidation reactions that cause damage to cellular structures throughout our body. So acrolein is an aldehyde. Interestingly enough, by the way, on the organic acid test, arabinose, which is linked to invasive candida, is another type of aldehyde. And so when I think about a patient who has a lot of chronic illness, they've got chronic fatigue, autoimmune problems, gut issues, neurological problems, I'm always looking at the potential of toxic overload, or how much is their system having to deal with? Are they being exposed to things environmentally? Are they dealing with a lot of internal toxins from deranged metabolism, for example, or a lot of overgrowth issues within the gut, from bacteria to candida, even potentially to mold exposure? And we think about it, our liver is our detoxification organ. So if we put a lot of pressure and a lot of strain on the liver, right, it's going to have a hard time keeping up. And so phase 1, phase 2 aspects of our liver detoxification, much of it, particularly phase 1, is heavily geared to dealing with aldehydes. A lot of the P450 system of our liver is very much geared to dealing with aldehyde type of chemicals. And then, of course, we've got glutathione, which is a major part of phase 2. We talk about this information and a lot else, with regards to chemical exposure, toxicity issues in our Toxicity Mastery course through Integrative Medicine Academy. If you aren't yet using the organic acid test, or maybe dabbled with it or want to learn more about it, I would encourage you to look at a couple of our courses through Integrative Medicine Academy, the Essential Oat Mastery, which is the fundamental aspects of the oat, and our Advanced Oat Mastery, which is understanding the organic acid test at a very in-depth level. Each of those courses are offered through Integrative Medicine Academy. If you are a healthcare practitioner and would like to interact with us for lab consults, clinical troubleshooting, case analysis, you can become a member of our Functional Medicine Clinical Rounds website. We've also got some educational material on there. We have webinars, and we even have a practitioner forum where you can post questions to us on a daily basis if you choose. So more information at functionalmedicineclinicalrounds.com. If you need assistance in accessing lab tests like the organic acid test, like the GPL-TOX Profile, or other tests from Great Plains, and you can access those through Lab Test Plus. Lab Test Plus also will offer and provides a written interpretation of the relevant findings of these tests, provides what's called action step suggestions as well. LabTestPlus.com is the website. You can email questions to labtestplus@gmail.com. And if you have any questions about some of our other mastery courses through Integrative Medicine Academy, you can check out our website, integrativemedicineacademy.com, or you can email those questions to integrativemedicineacademy@gmail.com. I want to thank Great Plains Laboratory and Dr. Shaw for sponsoring these videos over the past many years, including many of the webinars. Always looking forward to doing more. Again, I'm Dr. Kurt Wohler for Integrative Medicine Academy. Thank you.